We're going to solve quadratic inequalities algebraically. Now we're going to do a four-step process on this. We're going to first solve the quadratic equation as if it was an equality. Now it's a quadratic, so it's got two possible solutions. Then we take those solutions, we plot those on a number line, which is going to give us intervals. In fact, it'll give us three intervals. And then we test a point within each interval. And if that test point on a given interval gives us a true statement back to our original inequality, then that is part of the solution set. And if not, then it's not part of the solution set. And these are going to be either and or statements as far as our solution set. And then we finally, after testing that, then we're going to write the solution set in set builder notation. So let's get started. So we got x squared plus 5x is less than negative 6. Well, again, we're going to solve these as if they are equalities. And rather than leaving that negative 6 over here on the right-hand side, I'm just going to add 6 to both sides. And now we got x squared plus 5x plus 6 is equal to 0. Now I've got to factor this quadratic. So I'm looking for two numbers that are going to multiply. The product is going to be 6 and the sum is going to be 5. And let's see, well, 3 times 2 is 6, and 3 plus 2 is 5. So my two factors on this are x plus 3, x plus 2 equals 0. Now we're going to set each factor equal to 0 and then solve. So we got x plus 3 equals 0, so that x is equal to negative 3. And then we got x plus 2 equals 0, or where x is equal to negative 2. All right, now we're going to plot those on a number line. And so let's say 0 is here, negative 2 is here, negative 3, let's say, is right there. Now, we've got three intervals. We got an interval in this direction. We have an interval between negative 3 and negative 2. And these would be open dots, by the way, because it's just simply a less than. And then we got an interval out here greater than negative 2. So in this interval here, let's choose negative 4. How about that? And we're going to plug that back into our original equation. So that would be, then we would have negative 4 squared plus 5 times negative 4. And is that less than negative 6? Well, let's see. Negative 4 squared is 16. 5 plus negative 4 is negative 20. And we would say, okay, is negative 4 less than negative 6? Well, no, it's not. So that interval fails. All right, let's choose something. 3 and 2 got to go somewhere in between there. That's going to be a pain. Let's just try 2.5. So we got 2.5 squared plus 5 times 2.5. We're asking the question, is that less than negative 6? 2.5 squared, I think, is, well, I'm not going to think, 6.25. Oh, that's negative, by the way. I'm about to mess up. All right, and then 5 times negative 2.5 is negative 12.5. Still asking the question, is that less than -6? Let me make sure I got that's -2.5. So we got 6.24 minus 12.5, and that's -6.26. -6.26. And is that less than -6? Yes. So that interval passes. Now that probably is going to tell me that the next interval is not going to, it's going to fail. So let's see. Well, we can substitute 0 in there. And 0 squared is 0, and 5 times 0 is 0. So and then the question is 0 less than -6? Well, the answer to that, of course, is no. And that interval fails. So our solution set here is between -2 and -3. So x, let's get our, write it in set builder notation. So we got x such that well, negative, so x has got to be greater than -3. So let's say -3 is less than x. X is greater than -3. And then x is less than -2. And you can see that's an and statement. Less than, and, less than, and. Catch what I'm doing right there. All right, let's try another one. Go through the same process. We're going to solve these as if it's an equality first. We're going to find two possible solutions. Then we're going to plot those on a number line, which is going to establish 3 intervals. We're going to test each interval into the original equation to see if it gives us a true statement, and if so, that interval is part of our solution set. So here we got x squared plus 11x plus 30 is greater than or equal to 0. Let's set that as an equality. The only thing I'm going to change here is the equal sign. Just doing that for the ease of this. So now I'm looking for two numbers that are going to multiply to 30 and add to 11. Multiply to 30, add to 11. I believe 6 and 5 can do that. 6 times 5 is 30. 6 plus 5 is 11. So I got x plus 6 times x plus 5. We're going to set each factor equal to 0 and solve. So x is equal to -6 and -5. And again, we're going to have some weird interval. So here, let's say that we got -5 right here. We got -6 right here. And these actually are going to be close dots because it is a greater than or equal to, greater than. That might give you a clue of what's getting ready to happen. All right, so let's do some testing. Well, let's use a test point. Let's say a -7 right here. Could do 10. That'd be easy math, but why don't I do 10? That'd make it easier. So then we'd have 10 squared, which is 100, going back to this original equation, plus 11 times 10, that's 110, plus 30, greater than or equal to 0. 210 plus 30, so 240. Well, that's definitely greater than or equal to 0, so this interval passes. Well, might as well choose, I guess, 5.5. So I got 5.5 squared plus 11 times 5.5 plus 30. Is this going to be greater than or equal to 0? That's -5.5. About to mess up again. -5.5. All right, -5.5 squared. That's 30.25. And then 11 times -5.5. Well, that's negative 60.5 plus 30. We're asking ourselves, is this greater than or equal to 0? All right, 30.25 minus 60.5 plus 30 equals negative 0.25. And is that greater than or equal to 0? Well, of course, no. So that interval fails. And let's choose something greater than negative 5. How about 0? That would be in that interval. So 0 squared is 0. 11 times 0 is 0. We got 0 plus 0 plus 30. 30 greater than or is 30 greater than or equal to 0? Yes. So this interval passes right here. So our solution set is anything less than negative 6 and anything greater than negative 5. And then we can write our solution set in interval notation, x such that x is less than or equal to negative 6, or x is greater than or equal to negative 5. Greater, or, greater, or, less than, and. Just a clue there. If you listen phonetically, it'll help you understand what am I getting ready to get into. Is it going to be an and statement or an or statement? Take it for what it's worth. We have solved quadratic inequalities algebraically.